Welcome to The Explainer. Today we're stepping into the truly fascinating world of advanced mathematics. We are specifically zoning in on the Cambridge AS and A-level syllabus 9709, but honestly, the master strategy we're about to unpack is absolutely vital whether you're tackling 0580, 0606, 4024, 4037, or even 4040. Now, we aren't just going to look at numbers today. I want you to completely shift your mindset. I want you to think of yourself not just as a math student, but as a paleontologist. Yeah, you heard me right, a paleontologist. Think about it. When a paleontologist discovers a priceless dinosaur bone, they don't just rip it out of the ground and chuck it onto a museum table, right? No way. They carefully, meticulously dig through the fossil layers. They brush away the dirt step by step, documenting exactly how that bone was positioned in the earth. In Cambridge mathematics, specifically when you're dealing with question type 3.9 on complex numbers and non-real roots occurring in conjugate pairs, you literally need to treat your exam paper exactly the same way. We are going to carefully dig through the layers of the question to reconstruct the perfect examiner-approved answer. Because, and this is crucial, finding the final answer is only a tiny fraction of the battle. Showing exactly how you unearthed it, well, that is where the real victory lies.
Okay, let's dive into this. Why do so many incredibly smart, highly prepared students lose easy marks on complex numbers? Seriously, it is one of the most frustrating things to witness as an educator. You know the math, you know exactly what a complex number is, you have spent hours and hours revising, and yet the grade simply doesn't reflect your actual knowledge. So what's going wrong? The harsh reality is that students are bleeding marks because they only provide the final, polished answer. They are entirely skipping the fossil layers of their methodology. They just write down the final route without showing the systematic, logical steps they took to actually get there. In the highly critical eyes of a Cambridge examiner, an answer without its foundational working is basically like a fossil without any geological context. It completely loses its scientific value. You need to prove to them not just that you know the destination, but that you are an absolute master of the journey.
The principal examiner reports consistently highlight one absolutely critical lifeline straight from the senior examiner's desk. It's all about method marks. The quote here says it all. Method marks can save you. Even if your final answer is wrong, showing your working secures the method marks. I really want you to think about that for a second. Imagine you're in the exam hall. You're stressed, the clock is ticking, and you make a really simple arithmetic error in the final seconds of a high-pressure question. You totally botch the final numerical answer. But if you have systematically laid out your algebraic processing, if you have shown your substitutions, and if your logical reasoning is clear on the page, the examiner is still going to award you the vast majority of the marks for that question. Method marks are your absolute safety net in the Cambridge syllabus 9709. They are quite literally the safety harness that catches you when a quick calculation slips.
So here is our roadmap for today's session. First up, we'll explore the conjugate pair trap. Second, we'll break down the core theoretical architecture. Third, we're going to look at the transformation. Fourth, we'll jump into a quick interactive workshop. And finally, we will lock it all in with the final system. Let's get moving.
Section 1, the conjugate pair trap. To really understand this, let's look at a scenario with two students, Alex versus Sam. I want you to imagine these two incredibly dedicated mathematics students sitting down to take their 9709 paper. Both of them totally understand the fundamental concepts of complex numbers. They both know exactly what a conjugate pair is. But when they are faced with a high-stakes question asking them to find the roots of a polynomial, both of them fall right into the examiner's trap, totally failing to secure those top marks. Let's analyze exactly what went wrong for each of them, so you don't make the same mistakes when it's your turn.
Let's start with Alex. Alex has a massive habit of over-explaining. He overloads his exam paper with raw mathematics facts. He writes down every single thing he knows about imaginary numbers. I squared equals -1, the quadratic formula, the whole shebang. But there is zero logical analysis tying it to the specific question. It's all superficial breadth, but it has no analytical depth. Meanwhile, Sam is a classic case of rushing. Sam spots the complex root, instantly writes down its conjugate, and completely rushes the calculation to get the final variable. In doing so, Sam completely ignores the command words in the prompt like show that or hence evaluate. So Sam also missed the analytical depth Cambridge examiners demand. Both of these brilliant students are leaving incredibly easy marks on the table because they simply aren't playing the game the way the examiner wants them to play it.
That brings us to Section 2, Core Theoretical Architecture, the strategy reveal. We really need to look past the superficial calculations here and understand the foundational principles. We need to understand the exact cognitive domains targeted by the Cambridge Assessment Framework. What are the examiners actually testing when they ask you about non-real roots occurring in conjugate pairs?
Listen, they aren't just testing your ability to flip a plus sign to a minus sign. Anyone can do that. They are testing your structured reasoning. They're testing your precise definitions and your ability to forge logical, causal relationships across totally different mathematical topics.
So the absolutely crucial point here is this core definition, which really forms the base layer of our mathematical fossil dig. Non-real roots occur in conjugate pairs. This is a deeply established mathematical principle stating that if and only if a polynomial has real coefficients, any complex roots must appear as a pair, a plus bi and its conjugate partner, a minus bi. And wow, this is where so many students trip up. You cannot just blindly assume that every single complex root has a conjugate partner. You must explicitly state, or mathematically verify, that the polynomial in question has real coefficients. If you omit that vital piece of evidence from your answer, you immediately lose the method mark, because your logical architecture is flawed. You have to explicitly prove to the examiner that you understand the precise conditions under which this theorem applies.
To help you structure this perfectly every single time, we use a framework specifically adapted for advanced mathematics. It's called the Peel framework: point, evidence, explanation, link. You make your mathematical point, which is identifying the root. You provide the evidence, explicitly stating that the coefficients are real. You offer your explanation, which is applying the conjugate root theorem. And then you link it right back to the question's specific context. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to it. When you use the Peel framework, you are essentially guaranteeing that your logic is bulletproof and totally examiner ready.
Building right on top of that Peel framework, examiners are desperately looking for a standardized sequence to award those precious method marks for your mathematical processing. Step 1. Identify the key elements from the text or the tables provided to you. Step 2. Apply the relevant mathematical principles, exactly like we just discussed with checking for real coefficients. Step 3. Execute your analysis with crystal clear working. Do not skip lines of algebra. I can't stress that enough. Step 4. Verify your results. Ask yourself, does the answer make logical sense within the given parameters of the question? And finally, step 5, present your findings in the correct format, using proper mathematical terminology and very clear annotation. If you follow this exact 5-step sequence, you are actively managing your examiner's psychology. You are making it incredibly easy for them to just check those boxes and give you full marks.
Let's move into Section 3, the transformation. Securing method marks, it is time to take all that theory we've just learned and practically apply it. We're going to look at how we can rewrite Alex and Sam's heavily penalized flawed answers into top-tier structured responses. We want answers that will have the examiner reaching for their green pen instead of their dreaded red one. This whole section is about turning your raw mathematical potential into actual realized marks on the exam page.
And this brilliantly illustrates the absolute golden rule of Cambridge 9709 mathematics. Analytical depth is always greater than superficial breadth. Think back to Alex. Instead of Alex's approach of shotgunning 10 loosely related facts about imaginary numbers onto the page, a truly transformed answer focuses deeply on the specific requirements of the prompt. It integrates cross-topic connections. Maybe it links the complex roots back to the fundamental theorem of algebra, or it connects to factorizing quadratics. When you stop just brain-dumping facts and start deliberately constructing a logical, deep proof, those red pen marks literally transform into green check marks. You show the examiner you aren't just memorizing formulas, you are mathematically analyzing the problem.
So here is your mathematics success blueprint. It's a highly effective 3-phase approach used by top-scoring candidates around the world. Phase 1, deconstruct. Identify the given information and break the complex problem into logical, bite-sized steps. Phase 2, solve. Systematically apply the conjugate pair theorem, ensuring you show every piece of your algebraic processing without skipping any steps. And finally, Phase 3, evaluate. Check the reasonableness of your answer and make absolutely sure it fits the context of the original question prompt. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, the interactive workshop, Digging for Marks. It is time to put your skills to the ultimate test. I'm going to present you with some raw mathematical data, and I want you to actively engage with this information.
We'll have a mental 60-second timer running for these challenges. This is the exact moment where you transition from being a passive listener into an active, high-scoring problem solver. So get your mental gears turning, because here we go.
All right, here is Challenge 1, the data scan. Take a good look at the data in front of us. We have two polynomials here, p of x and q of x. I want you to extract the core trend from this table and mentally fill in the missing conjugate pairs. The clock is ticking in your head right now. Look very closely at the coefficients column. Do you notice how it explicitly states real for both of them? That right there is your absolute green light. Because the coefficients are definitively real, the established principle perfectly applies. So for polynomial p, if the known root is 3 plus 4i, the missing conjugate root absolutely must be 3 minus 4i. And for polynomial q, with a known root of negative 2 minus I, the missing root is exactly negative 2 plus I. It might seem super simple, but the ability to quickly scan data tables for that specific real coefficient condition is a vital exam skill.
Awesome. Now for Challenge 2, find the flaw. Read this sample student answer very carefully. The root is 3 plus 2i, so the other is 3 minus 2i. X equals 5. I want you to channel your inner principal examiner right now. Where exactly is this student bleeding those critical method marks? Take a second to read it again. What is missing? Well, first off, there is absolutely zero context. They haven't stated why the other root is 3 minus 2i. They completely failed to mention the crucial fact that the polynomial has real coefficients. Second, look at that sudden, jarring jump to x equals 5. There is no working out shown at all to explain how they arrived at that final value from the roots. It's vague formatting, it's poor presentation, and honestly, it's a guaranteed way to lose method marks.
And you know what? That perfectly aligns with the direct insider intelligence we pull straight from the principal examiner reports. Here are the top 3 examiner warnings you absolutely must memorize. Warning number 1. Answers are often far too vague. Cambridge examiners don't want broad, general statements. They want specific, targeted mathematical details and explicit justifications. Warning number 2. Poor format and presentation conventions. Listen, if your variables aren't clearly defined, or if your algebraic steps are just jumbled all over the page without any logical flow, you are going to lose marks, period. Warning number 3, ignoring the specific context of the question. If a question specifically asks you to, hence, evaluate based on the previous parts you just solved, and you decide to start completely from scratch using a totally different method, you are ignoring the context and the command word, and that will cost you dearly.
Which brings us to Section 5, the final system. Let's wrap this all up. It is time to synthesize every single thing we have covered today into the ultimate strategy cheat sheet for the Cambridge Syllabus 9709. We've looked at the common traps, we've analyzed the core theoretical architecture, we've actively transformed poor answers, and we've practiced spotting crucial flaws. Now, I'm going to give you the complete answering system. If you follow this systematically, it will absolutely maximize your mark potential and transform you into a top-tier candidate.
Here are the 3 non-negotiable rules of your final system. Rule 1. Command word decoding. You must always start by identifying what the question is explicitly asking you to do. Is it asking you to state, to show that, or to solve? Your entire strategy pivots on that one word. Rule 2. Peel framework application. Make your point, provide the solid mathematical evidence, like establishing those real coefficients we talked about. Explain your processing step by step, and link it right back to the solution. Show the examiner those fossil layers. And Rule 3. Time management matrix. Don't spend 10 minutes agonizing over a 2-mark question, and definitely don't rush blindly through an 8-mark problem like our friend Sam did earlier. You have to allocate your time directly based on the specific mark weighting of the question in front of you.
And why does all of this meticulous strategy actually matter? Because of the number 2. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
I really want to leave you with one final provocative thought as you head back to your revision notes today. When you sit down in that exam hall, when you stare at your paper and you grip your pen, will you just write down the answer, or will you show the examiner exactly how you unearthed it?
Remember the metaphor from the beginning. Be the paleontologist. Deliberately brush away the dirt, reveal the beautiful layers of your mathematical working, and secure every single one of those critical method marks. Thank you so much for joining me on this deep dive. Keep practicing, stay structured, and I will see you in the next explainer.